Before starting the lab, make sure everyone has on the right attire, including their goggles. Using a pipette, we begin by transferring some of the stock solution into a cuvette. Make sure that the meniscus does not pass the cuvette marking. We will prepare a blank cuvette in the same way. Next, we will begin transferring our dilutions into the cuvettes as well, following the same technique.
The spectrophotometer is used to measure intensity as a function of the light source wavelength. Before using the spectrophotometer, make sure that the wavelength is set to 560 nanometers. Now, using the lab tissues, clean off the sides of the cuvette containing the blank that the light will pass through. Then, close the lid of the spectrophotometer and click 0. When you zero the spectrophotometer with the blank cuvette, you are eliminating the values for light absorbed by the cuvette in addition to its contents. Now, we repeat this process with the stock solution, first dilution, second dilution, and third dilution instead of the blank. Instead of zeroing the cuvette value, press scan and record your values in your notebook.
The relationship between concentration and absorbance is defined by Beer-Lambert law, also known as Beer's law. The equation that represents this relationship is absorbance equals wavelength times path length times analytic concentration. The absorbance is found by the spectrophotometer, and the path length is 1 centimeter because of the cuvette, and the concentration can be found by M1 times V1 equal to M2 times V2 for each solution.
The reason why you should scan across all wavelengths when using a spectrometer is to form a standard curve for a graph, and also to find the lambda max. The lambda max is the wavelength along the absorbance spectrum where a substance has the strongest photon absorbance.
Now it is time to clean your lab materials. All solutions can be poured down the sink. Thanks for watching.